So AWS VPC see AWS VPC stands for Virtual Private Cloud. So yesterday what we have seen, so we have designed VPC with HS setup, and today we are supposed to see that practically. But as you are asking, so I'm explaining the concept once again. See, I already explained you AWS global infrastructure, right? So if you see AWS global infrastructure clearly, we have 32 launched AWS regions. Okay. Okay. So 102 availability zones, 550 plus points of presence, and 13 regional edge caches. So if you see this map, world map, okay, particularly in India, we have around three availability zones, okay, two regions, and each region consists of three availability zones, okay. But if you see here, North California has three availability zones, which was launched on 2009, and if you see London, okay, this London region has three availability zones, and Spain has three availability zones, and Beijing has three availability zones. North Virginia, if you see this, US North Virginia, 1 minute, yeah, it was launched in 2006 and it has six availability zones. అంటే ఈ availability zones అనే differs based on the regions. Okay, for example, if you see our Mumbai region, it has three availability zones, but if you see North Virginia, it has six availability zones. Okay, I already explained you, like, see AWS, if you see AWS data center images, okay, so like you can consider this as one availability zone. Okay, each availability zone consists two or three data centers. Okay, but see, for example, if you see this AWS global infrastructure, Mumbai region or Hyderabad region has three availability zones. Okay, so this might be, this set is like one availability zone, and if it is in Warangal, second availability zone is in Hyderabad, and third availability zone might be in Hyderabad Bangalore highway, like near to Bangalore or Hyderabad highway. So see, అంటే ఒక ప్లేస్ లోనే AWS కంప్లీట్ గా అన్ని అవైలబిలిటీ జోన్స్ పెట్టారు. సో ద రీజన్ ఐ హావ్ ఎక్స్ప్లెయిన్డ్ యూ, ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఎనీ డిజాస్టర్ అకర్స్, ఓకే, ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఎనీ డిజాస్టర్ అకర్స్, so your data should be highly available in different availability zone also. That's the reason why Amazon has segregated its availability zones far away from one to another. Okay, okay, for example, if you see here, North Virginia is launched in 2016, so AWS has launched its region in North Virginia in 2006, and it consists of six availability zones. Okay, how can I see that? So if you go to AWS console, okay, and choose North Virginia, US East 1, okay, click on this region, okay, and go to EC2 service. Here you can see US East 1, okay, and you can see six availability zones: US East -1A, US East -1B, 1C, 1D, 1E, 1F. Okay, see this one, North Virginia has six availability zones, but our Mumbai region is having only three availability zones. సో ఈ అవైలబిలిటీ జోన్స్ అనేది ప్రతి రీజన్లో త్రీ ఉంటాయంటే కాదండి. ఓకేనా, depends upon region. Okay, as I have shown you, North Virginia consists of six availability zones, and if you see this, uh, Ohio consists of three, and if you see this Europe, it consists of three availability zones, and Paris, European countries and all consists of three availability zones. Okay, but if you see here Oregon, again, okay, here if you see this Oregon, so it consists of again five availability zones. Okay, so అర్థమైందా? సో డిపెండ్స్ అపాన్ ద రీజన్ అవైలబిలిటీ జోన్స్ differs. In Mumbai we are having three availability zones, in North Virginia six, in Oregon you have five. Okay, okay, fine. Now if I consider Mumbai region or US East -1 North Virginia, whatever it might be, it has three availability zones. Our Mumbai region is having three availability zones, One availability zone is called AP-South-1A, okay, and another availability zone is called AP-South-1B, and another availability zone is called AP-South-1C, okay. So this is Mumbai region, okay, AP-South-1, okay. And if I can go to EC2 console and choose Mumbai region here, AP South 1, okay. See, you can see here Asia Pacific Mumbai, it is having three availability zones. Zone name is AP-South-1A, 1B and 1C, and these are the zone IDs, okay. Okay, fine. Okay, fine guys. So without VPC, so let's forget about VPC. Without VPC, let's assume few scenarios. For example, if I launched one instance in AWS, okay, if I launched one instance in AWS, I already told you in AWS terminology we call servers as instances. Okay, na? So we call servers as instances. So for example, if I launch server 1 in AP-South-1A availability zone, and I will name this server belongs to Hyundai company. Okay, Hyundai. Okay, and we are launching one more instance. Okay, called Suzuki. Okay, Suzuki. Okay, okay. Or let's forget about this scenarios first. Okay, for example, this two servers belongs to me. Okay, these two servers belongs to me only. Okay, these two servers belongs to me, my company. Okay, so there is a requirement in the organization that this server 1 needs to communicate to server 2. Okay, okay, this server 1 needs to communicate to server 2. So how it used to be in olden days, there used to be like every organization will have one networking team, guys. So there will be one network adapter. Okay, let's assume this as your network adapter. Okay, where this network adapter access will have especially to your security, sorry, your network name only. Okay, then your organization, what you will do, guys, if these two servers wants to communicate with each other, you will go and raise a request to your network name that I need to communicate these two servers, please do required configuration. Okay, once your manager approved that request, then okay, once your manager approved that ticket which you have raised to your network team, then what it will happen, network team will implement your ticket based on the description, like you need to communicate between, okay, these two servers. Okay, then what they will do, guys, they will configure some configuration in this their network devices, so that the communication between two servers will happen successfully. Okay, two servers will communicate successfully. Okay, okay, okay. So but in aws guys, but in aws our network team also won't get access to these physical network devices. Okay, everything in backend, everything will be managed by aws itself. Okay, backend, everything will be managed by aws itself. So in aws, by default, okay, by default, each availability zone will be connected to each other by default. Okay, see, like this. Okay, by default it will be connected internally. That is the backend configuration done by aws itself. Okay, okay, anta bane undi, fine. See, this is how the availability zones are interconnected by itself by default. For example, guys, let's assume Hyundai, guys, okay, Hyundai guys launched their instance in Mumbai region AP-South-1A. Okay, and Suzuki guys also launched their instance in AP-South-1C availability zone. So as Honda is different customer and Suzuki is different customer, if three availability zones are connected internally by default, these two servers can also communicate with each other. No, these two servers also can communicate with each other by default, right? So here the main problem is, can you guess, someone guess what is the main problem here? Hmm? See, by default if servers are communicating with each other, then what is the main drawback guys here? What is the main drawback? The main drawback is security. Okay, security. So Hyundai can see the data of Suzuki, Suzuki can see the data of Hyundai. So there is no security here, right? There is no security. Okay, so that's why Amazon came up with one service called VPC. Okay, for example, okay, for example, if I launch if I launch this Hyundai server in one VPC, okay, if I launch this Hyundai server in one VPC and this Suzuki server in another VPC, okay, Suzuki server in another VPC. Now, even though availability zones are internally connected by default, these two servers cannot communicate with each other as they are in different VPCs. Okay, అర్థమైందా? So VPC we use it for segregation, and that is a virtual private cloud. Okay, virtual private cloud. Okay, where we define our network and launch our resources in that network only. Okay, so now see, now I have launched Suzuki server in one VPC and I have launched Hyundai server in one VPC. Now, even though availability zones are interconnected by default, these two servers won't communicate with each other now because they are in the different VPC. Yes, if you want, they will communicate with each other, but not by default. There is separate configuration which we need to do, that is called VPC pairing, which we are going to see in further classes. Okay. For example, now how traffic will come to this server? Using internet gateway. Internet gateway. See, you can configure one internet gateway like this to your VPC. So if someone, like if some customer is hitting your server, if some user wants to access your server, some group of users wants to access this Hyundai server. Okay, if they are having all the details, first the traffic will come to gateway, and from gateway it will be routed to this server guys. Okay na? This server. So like this the traffic will come. Similarly same for this server as well. Okay, first the traffic will come, if someone is hitting Maruti Suzuki server, the traffic will come to internet gateway, from internet gateway to this server. Like this the communication will happen. Okay, but by default these two servers won't communicate with each other by default right now because they are in the different VPCs. Okay, okay, but here see, without VPC, see what's the scenario here. You understood the main difference, right? Have you understood the main difference here?
Yes, sir.
Hello. Yeah, so see, yesterday we have designed a VPC. Like, see, we have designed one VPC and we have created one internet gateway. See, I am writing it down. So okay, design the network. Okay, design the network with 10.1.0.0/16 CIDR. CIDR stands for classless interdomain routing. Okay, where Amazon supports network mask from /16 only. It won't support /8. Okay, from slash 16 17 up to 32 you can define your own network range. Okay, so how many IPs are possible in the given network range? So there are 65,000, 2 power 32 minus 2 power 32 minus 16, 65,000 IPs are possible in the given network range. Okay, so in the pattern, this is a huge network, right? 65,000 IPs, this is a huge network. Let's divide this network into parts called subnets. Okay, we have divided yesterday what we have done, we have divided this huge network into parts called subnets. Again guys, subnets are two types. Subnets are two types, one is public subnet and another one is a private subnet. So why we have divided subnets into two categories guys? Why we have divided subnets into two categories, into public and private? Simple, see, interview question. First they will ask you, what do you mean by public subnet? You should say that, sir, if two subnets are having a direct route to internet gateway, we call those subnets as a public subnets. Okay, see guys, in this huge network we have divided into parts called subnets. These two are private subnets and these two subnets are public subnets. Now these two subnets are officially public. Why? These two subnets are having a direct route to internet gateway. That means, for example, if you launch any server in the public subnet, either of the public subnet, see, I have launched one server in the public subnet 1A in API-South-1A availability zones. That means I can have direct access to this server from internet. That means this server 1 will get automatically, Amazon will assign public IP address to this server. Okay, whenever guys you launch the subnet in this public subnet, Amazon will assign a public IP to this server, so that if I deploy some website in this server, okay, if I deploy some website in this server, if I give that public IP to my customers or my friends or my family members something, okay, they can access my website from the internet using that public IP. Okay, and also I can download any packages from the internet. Okay, okay, then what is private subnet? What is private subnet? Guys, private subnets, okay, are the subnets which is not having a direct route to internet gateway. Instead, to connect to the internet, we use a concept called NAT gateway. Okay, you define, see, what are public subnets? The subnets which are having a direct route to internet gateway are called public subnets. Ante enti? See, have we directly added a route to internet gateway? No. There is one more device called route table. Okay, there is one more device called route table where we define all the routes. Okay, where we define all the routes. Okay, okay, now what I have done, I'm naming these two servers, these two subnets as public subnets. No, how to call them officially? We need to add these two subnets in this route table. Then from this route table, after adding these two subnets, you need to pass the route to internet gateway. Then only officially we can call these two subnets as a public subnets. Okay, okay, see, first we are divided this network into parts called subnets. Subnets are two types. Okay, one is public subnet and another one is private. So guys, I have launched two public subnets in different availability zones. You can also create any subnets in same availability zones. That's not a big deal. I will explain you the reason why I have created two public subnets, but in the different availability zones. I will tell you. Okay, similarly private subnets also, I have created two private subnets in different availability zones. Okay, so first let's design the VPC. Okay, we bifurcated them into subnets. Subnets are two types, public subnets and private subnets. Now what we need to do is create two public subnets. Okay, create two public subnets. Next point, create two private subnets. Now, in order to call these two subnets officially as a public subnets, what I need to do, guys? I need to create one route table, create one public route table. Okay, create one public route table, and seventh step, add two public subnets. Okay, అంటే ఇంకా అఫీషియల్ గా పబ్లిక్ అవ్వలేదు ఇది. Still these two subnets are officially not public because we need to add these two subnets in this route table, and we need to pass the route to internet gateway. Then only officially we can say these two subnets as a public subnets. Okay, now add two public subnets under name. I'm calling it like that. Okay, add two subnets, two public subnets in the public route table, in this route table guys, which we have created. Okay, add two public subnets in the public route table. Okay, and sorry, here one more step we forgot. Third step is create one internet gateway. Okay, create internet gateway called, you can call it as IGW with shortcut. Okay, create one internet gateway and attach to VPC. Okay, this is my fourth step, this is my fifth step, this is my sixth, seventh, and eighth step. Okay, so add two public subnets in the public route table and pass the route to internet gateway. Okay, internet gateway IGW. Okay, see now these two subnets are officially, we call it as a public subnets because we have created two subnets and created one route table and added these two subnets to this route table and passed the route to internet gateway. Okay, so okay, fine. So next step is next step is create, okay, individual route table, individual route table. We can call route tables as RT in shortcut. Okay, create individual route table for each private subnet. Okay, for each private subnet. Okay, so why I am creating the individual route table guys? Why I am, see, for public subnet, see, for public subnet we have only one route table, no? Can anyone tell me why I have created two separate route tables for private subnets? Can someone tell me why I have created two separate route tables? You know, I ask, sir, for public subnets you have created only one route table and added two subnets and passed the route to internet gateway. But for private subnets, why you have created two route tables? Can someone tell me? Any guess? Try to answer this. Hmm? Try to answer. Okay, I'll tell you the reason. See, for example, guys, in real time we launch servers in private subnets only. Okay, due to security. Okay, okay. For example, I have server 1 in the private subnet 1A. Okay, and this contains, this server contains my website. Okay, my e-commerce website. Let's say, let's say Flipkart. Let's say Flipkart or Myntra. Flipkart. Okay, and I have same setup, same application in server 2 as well. Okay, in server 2. Okay, fine. This server 2 I have launched in private subnet 1B, and this server 1 I have launched in private subnet 1A. Okay, okay. Now from the internet successfully the traffic is coming to my both servers. Okay, so when you're accessing Flipkart website successfully, the traffic is coming to both servers. Okay, for example, for example, okay, for example, if you add this subnet also, Okay, for example, if you add this subnet also in this route table, okay, see now also successfully the traffic is coming from the internet like this, like this, like this, to these two servers. The traffic is coming fine, there is no doubt in that. Okay, let's assume, let's assume from the AWS side. Okay, see we have seen this availability zone law. This is ap-south-1a availability zone. See, now from the internet, when customers are accessing my Flipkart website, the traffic is coming to 1a availability zone NAT, to this and to these two servers. So see, traffic is not coming to this server via 1b. Okay, for both servers, see the traffic is coming via 1a availability zone only. Okay, for example, in AWS side from the back end, there is some disaster, there is some disaster. Okay, there is some disaster and 1a availability zone. Okay, there is a zone called 1a availability zone, no, in Mumbai region, ap-south-1a availability zone. This complete zone went down. Okay, this complete zone went down. Now when I hit flipkart.com, it is saying that this site can't be reached right now. Okay, this site can't be reached right now. Okay, so Amazon engineers fixed this issue after 3 hours. Okay, fixed this issue after 3 hours. For example, for 1 hour my business revenue is 10 crores. Okay, how much business I lose, guys? 30 crores of business is lost due to this 1a availability zone down. That's why in real time in our organization also, the VPC setup should be highly available. Okay, this is not high availability setup. For example, if one availability zone went down, the traffic must come like this. But 1a zone went down, no, it can't reach to the, it can't reach to my server 2 as well, because we have configured the route to be from 1a availability zone. That's why this setup is absolutely a failure concept. Okay, now see, now see, now if you have individual route table for each private subnets in different availability zones. Okay, now customer hit traffic to Flipkart. For example, this 1a availability zone goes down now. Now let's assume again this 1a availability zone went down. Sorry, yeah, this 1a availability zone went down. Okay, now see my load balancer. Okay, my load balancer, what it will do, see, if this availability zone went down, automatically the traffic will come to this server. So that's why when you are accessing Flipkart website, automatically the request is being routed to this server now, like this, like this the traffic will come and go. Okay, understood, guys? So why we have added only one route table to public subnets? Because anyways this subnet should have direct route to internet gateway. That's why we have created only one route table and added these two subnets and passed the route to internet gateway. But in case of private subnets, it's a different scenario. Have you all understood it very clearly, or shall I explain it one more time, guys? Hello, have you understood why we have created two individual route tables for private subnets? Mohammed?
Yes, sir.
Yeah, yeah. Okay. See, now create one individual route tables for each private subnet and pass the, sorry, create one individual route table for each private subnet. Okay, you need to create two individual route tables for each private subnet. Then you need to create two NAT gateways in each public subnet, in this public subnet and in this public subnet. Okay, let's write it. So create two NAT gateways, call NAT gateways, NGW. Okay, in each public subnet. Okay, in each public subnet. Next, add each private subnet in their respective route table, respective route table. Okay, add each private subnet, in their respective route table, and pass the route to their respective NAT gateways in public subnets. Okay, add each private subnet in their respective route table and pass the route to their respective NAT gateways in public subnets. Okay, okay, fine. Now our is 12th step is prove that prove that okay, our 12th step is prove that the traffic from internet is coming to the server and vice versa. Okay, after completing this setup practically, now what we need to do, guys, I will launch one server in this public subnet or in this public subnet. Okay, and I will deploy one sample website, and I will try to access the website with the public IP, so that I can successfully prove that the traffic is coming from internet to my server successfully, and also from server traffic is going out successfully. Okay, now let's create this VPC. Let's create this VPC practically by hands on. Okay, now after signing into your AWS console, search for VPC. Okay, search for VPC. Now already Amazon will give you one default VPC, guys. Okay, you need to create. See, I am deleting this VPC. This is for created for previous batch, so I'm deleting this VPC. Okay, for example, if you log into the console, okay, and went to VPC, there will be one default VPC which will be given by Amazon for you. Okay, you can use that as well, but we need to create our custom VPC. Okay, we need to create our custom VPC. For example, see, in Mumbai region I have deleted that default VPC given by Amazon. For example, if you choose different availability zone, like US East -1, okay, so there will be, see, there will be default VPC. This is given by Amazon. Okay, in Mumbai region I have deleted that. Okay, okay, let's create our custom VPC, our own VPC. Okay, see, guys, I want to tell you the pricing model as well. Okay, uh, VPC, internet gateway, subnets, route tables is free of cost. You no need to pay single penny to Amazon, guys. Okay, okay, and also it won't generate in AWS billing, but AWS will charge you when you create NAT gateways. So once the practice is done, you need to delete this NAT gateways in the console. And also when you create this NAT gateways, there is one more concept called elastic IPs. Okay, I will tell you that, not an issue. And they will charge you for elastic IPs as well as for NAT gateways. Okay, remember, remaining rest is free. You can create VPC, internet gateway, subnets, route tables. These all are free, but they will charge you for elastic IPs and NAT gateways. Remember that point. Okay, fine. Okay, let's go to VPC console. Click on create VPC. VPC only. I'm calling it as version IT. Okay, version IT hyphen VPC. Okay, so CIDR range, what we have defined CIDR range, guys, you can take CIDR range from anywhere. Okay, from any of the range. For example, if I am taking 10 series, okay, 10.1.6 0.0/16. Okay, tenancy. See, this is an important parameter. Remember, when we are coming to EC2, there is a separate 15 minutes class for this tenancy only. As of now we are going with default only. Okay, and tags. Okay, tags automatically name it took from here, version IT VPC. And you can add tags like created by funny. Okay guys, tags are nothing but like we can use it for identification. Okay, for example, if in your organization if someone clicks on VPC, they see tags. We can define tags like this. Okay, it matters, right? It makes somewhat sense. Like if someone visited to my VPC console and have seen these tags, okay, they will get to know that okay, this VPC is created by so and so person, and it was created on this so and so date. Okay, created on. Okay, created on 15 hyphen sept hyphen 2023. Okay, purpose. You can give practice. Okay, practice something, whatever the tags you want you can create in the AWS tags console. Okay, just click on create VPC. Now see guys, successfully we have created our VPC with 10.1.0.0/16 ADR. So as discussed, you are going to get 65,000 IPs in this huge network. Then we are bifurcating this huge network into parts called subnets, right? Okay, then again we are calling subnets as two types: public subnets and private subnets. We are creating here two public subnets and two private subnets. No, out of 65,000 IPs guys, I need only let's assume 200 plus IPs. Okay, this subnet I want 200 plus IPs, this subnet I want 200 plus IPs, this all require 200 plus IPs. Okay, then in future if I want I will create another subnets. That's not a big deal, but as of now my organization requirement is to design a subnet with only 250 IPs. So how will you give CADR range for this subnet if you require 250 IPs only? See, okay, what is our next step? Create one internet gateway and attach to VPC. First we'll do that, then we'll come to subnets. Okay, go to internet gateways. Okay, create internet gateway demo. Like I can give version id. Okay, version id hyphen igw stands for internet gateway. I'm giving it like that. Again, if I come to tags created by honey and add one more tag, created on 15 hyphen sept hyphen 2023. Guys, if you go to any organization, try to maintain tags like this. Why I am telling you is, when someone see this resource they will understand that okay, so and so person created this resource, so and so person created this resource on this particular time. Okay, and so person created this resource for this particular purpose. This is the best practice. uh, as a team lead in my organization, I always tell these points to my team, but no one follows. Again, I see the different CloudTrail logs, then I update tags myself. Okay, so this is the best practice. Okay, now they are habituated, that's different case after scrolling 2 to 3 times. Okay, but this is the best practice. Okay, now when someone is saying this resource, okay, easily they will understand. Okay, so and so person created this resource for this purpose on this date. Okay, they will get clarity. Okay, when audit is going on they will get clarity. Okay, created time, you can give one more tag as well, created time. Okay, how much time is 8:43 a.m. 8:43 a.m. IST, Indian Standard Time. Okay, so like that you want to, if you want to give any tags, okay, any tags you can give. Purpose. Okay? I'm adding one more tag called purpose. Practice. Okay, practice. Just create internet gateway. Now see, I have successfully created one internet gateway. Okay, now what is our goal? What is our goal? Create one internet gateway and attach to our VPC which we have created. Okay, so go to actions, attach to VPC, select your VPC in the drop down and click on attach internet gateway. That's it. So we have created one VPC and one internet gateway and attached that internet gateway to VPC. Next, what is our step, guys? Create two public subnets. Okay, create two public subnets. So go to subnets, okay, and create subnet and choose your VPC and give subnet name. I can give funny subnet, okay, or I can give Nagmani subnet, Manisha, Rakesh, Rita, Lokesh, Satish, Tripat, any me name Bhavana, okay, Mohammed subnet, okay, Niveda subnet, I can give any name, but according to the proper, see, in order to understanding it very easy, guys, I'm defining the naming convention like this, okay, version id, okay, version id public subnet 1a. Why I am giving name as 1a, guys? Can someone guess why I am giving this subnet name as 1a? By seeing this diagram, can someone guess? Tell me why I am giving this subnet name as hyphen 1a at the last. Come on.
Yes, server 1 లో లాంచ్ చేస్తున్నాం కదా సార్.
Availability zone 1, server 1. Okay, availability zone. Okay, so we are, see, why I am naming version IT public subnet 1a, because I am going to launch this subnet in AP-south-1a availability zone. Okay, now go to availability zone and select AP-south-1a. Okay, now as per the discussion, I want 250 IPs, 250 IPs for all the subnets. This subnet need 250 IPs, 200 plus IPs, let's assume. Okay, 200 plus IPs. So how I'm defining the CIDR ranges? 10.1.1.0/24. So yes, if I give /24, 2 power 32 minus 24, how much? 2 power 8. 2 power 8 is 256. So I'm getting 200 plus IPs now. But Amazon will give you only 251 IPs in this subnet. Okay, only 251 IPs are possible in this subnet. Then what about rest 5 IPs? Then what about the rest of 5 IPs? It will be reserved by Amazon for future use. I will explain you those. Why 5 IPs will be reserved by Amazon for future use. Okay. See, I'm giving 10.1.0.0/24. Okay, and I'm creating one more subnet called version IT public subnet 1b. Okay, and I'm going to launch this subnet in AP-south-1b availability zone. Okay, and CIDR range I'm giving 10.1. Here we given 1, no, give 2. 10.1.2.0/24. Okay, click on create subnet. Okay, click on create subnet. Don't forget to give tags. Give tags, just basic tags created by sorry created by honey and created on 15th Sept 2023. Okay, and same tags I'm using for this subnet as well. Okay, so created by honey. Okay. So why I am giving tags for all the resources? See, when you are seeing this video and practicing, so you will get habituated to give tags for each resource. Okay, so the important thing is created on 13th Sept 2023. Okay, fine. So click on create subnet. Now successfully we have created two subnets, these two public subnets, but still these two subnets are not officially a public subnets because we haven't created any route table and added the routes to internet gateway by adding these two subnets, right? What is our next step now? Create two guys, I'm doing the setup only up to public subnets. Private subnets I will do it later, okay? Once in, when we are seeing the ec2 concept at the end of the ec2, this setups we will do. As of now we will launch servers and all and practice all the concepts in the public subnets only, okay? So next step is create one public route table, okay? So go to VPC and go to route table section and click on create route table and create one route table, okay? Version 90, okay, hyphen public hyphen route table, okay? And choose your VPC and add tags created by honey and add one more tag created on 15th hyphen sept hyphen 2023, okay? Fine. Create route table. Now successfully we have created this route table. Then what is the next step? We need to add these two subnets in this route table. So go to your route table now, okay? See, this is our route table, right? So version ID public route table. So click on this route table ID and go to subnet associations and click on edit subnet associations and select these two subnets and save associations, okay? Now successfully I have added these two subnets in this route table as you told. So next step, what is the next step? What is the next step? What is the next step? To call
Di-
officially
di-
these two subnets, huh?
Direct route to connect to internet gateway.
Good, Satish, good. So yes, in order to call these two subnets as a public, I need to pass the route from this route table to internet gateway. Just go to your route table. See here. See. Now we have added two subnets, right, in this route table. These two subnets we have added successfully. Now click on this route table and go to route section. Click on edit routes and click on add route. 0.0.0.0/0. This stands for anywhere, okay? Anywhere, destination, anywhere, okay? Target internet gateway. Choose your internet gateway and click on save changes. That's it. Our VPC setup is done with public subnets as of now, okay guys? Okay, good, we are done. Good setup of VPC with public subnets, but you need to do some settings. You need to configure some settings to these two public subnets. Just simple. Okay, for public subnets we need some settings. Let's see what is that. Go to your subnets. Okay, select your subnet. Okay, click on actions, edit subnet settings, and enable this option. Okay, enable this option. Okay, what is this option? Auto SN public IP address, auto SN public IPv4 address. That means for example, if I launch any server, okay, if I launch any server in this public subnet or in this public subnet, automatically Amazon will assign one public IP to this server. Okay, that is the meaning of this. Okay, auto assign public IP and enable resource name DNS a record on launch. So Amazon also will assign one DNS name to this server. Just save this, and similar setting you need to perform for 1 year subnet as well. Go to subnet settings, edit, and enable these two options and save. Now what is our goal? What is our goal? To prove that traffic is coming from internet to this server and vice versa. Forget about this private subnets and private route tables, NAT gateways. Those we will see later in middle of EC2. Okay, See guys, why I am telling you this subnets, private subnet concept in middle of EC2 is, see, first you need to have knowledge on EC2, how to launch the servers, how to deploy websites in the server. Okay, then we will perform this setup. That's why I am that's why I'm planning to teach you this private subnet concept in between of EC2. Okay, so as of now we have designed VPC and two public subnets, right? Now I need to prove I need to prove that the traffic is coming from the internet, and also from the server the traffic is going to internet. Okay guys, you should be perfect up to here. Only public subnets, VPC, internet gateway, and one public route table. Now I am proving that the traffic is coming from the internet. That means I need to go to a service called EC2. Okay, this is not yet introduced to you. Once again I'm saying, forget about this. I'm just testing whether my VPC is correct or not. Okay, I'm just trying to prove that the traffic from the internet is coming to our VPC or not. In order to do that, I need to launch one server in this public subnet and deploy one website, and with public IP I should be able to access this website in this server. Guys, you be thorough up to here. Okay, don't take this from now, from 8:56 a.m. I'm telling you EC2 instance, like I'm just trying to prove that traffic is coming from the internet. That's why I'm launching EC2 instance. Still, EC2 introduction is not at all discussed with you. There are lot of things we need to discuss in EC2. Okay, this is separate service. Tomorrow we are going to see this service in detail. Okay, after seeing this video, you okay, then don't say that you went fast from EC2. This is not at all introduced to you. Okay, okay, just see this, that's all. Okay, so I'm launching one server. Okay, all these parameters will be taught to you tomorrow. Okay, so I'm launching one server guys in this availability zone. Okay, okay, so the server got launched in public subnet 1B. Okay, in this availability zone we have launched one server. Okay, now I will deploy some sample website. Okay, so all these concepts will be taught to you tomorrow morning. Okay, this is just for proving that whether the traffic is coming via internet to my server or not. Okay, ఇది మీకు ఇంకా అవ్వలేదు. Still this is not at all introduced to you. I'm doing to prove that the traffic is coming via internet or not. Okay, see, now I'm deploying one sample website, and I will give you the public IP of this server and check whether our website is working or not. Okay, so I will go to GitHub and take some sample HTML website GitHub. static website GitHub. Okay, I got some sample website from GitHub. Let me deploy this in this server. Guys, I'm deploying this sample website from GitHub to my server, and I will give you public IP. Just check whether that is working or not. Okay, now let me go to my EC2 instance and see I have here public IPv4 address. So I'm trying to hit this in the browser. See, this is my sample website which I have deployed in the server. So how? See, I'm giving you this website IP in this chart as well. Just check whether it is working or not. All of you check this out. In message box I have pinged you the IP address. Okay, just let me know if it is working. Let me know the status, it's working or not. Is it working?
Yes, sir, working.
Yes, exactly. So we have proved that traffic is coming from the internet, right? See this diagram. See, our people started hitting my website in the server. See guys, how the traffic is being routed via internet gateway. See, via internet gateway. Okay, like this, the traffic is coming to my server. Okay, okay, understood? Everyone understood? Okay, Satish. So everyone understood, guys?
Yes, sir.
Hello? Yeah, practice this. Practice. So up to VPC, you need to practice only up to VPC. Just keep this VPC setup ready. Okay? VPC setup ready and two public subnets and one internet gateway, one route table. That's it. Tomorrow we are going to introduce. Tomorrow I'm going to introduce EC2 stands for Elastic Cloud Compute. We are going to learn different instance. We call servers as instances in AWS terminology. We'll see in depth about instances types, instances categories, pricing models, what are the different flavors Amazon is offering, what are security groups, elastic IPs, load balancers, auto scaling. For example, if 1 lakh requests come to my server, how to handle the traffic by using a concept called hot auto scaling with launch templates, launch configurations, okay, user data scripts, everything. EC2 will take around 7 to 10 days. That is the main service which we need to focus in AWS while learning. Okay, okay now guys. Okay, so practice this. So set up your VPC and be ready up to public subnets part. Then we are going to see EC2 introduction tomorrow. Okay, thank you.